I think we have some of the foremost experts on leak detection anywhere in the country. Not only this country, but North America, I guess I should say, because Canada is doing some pretty exciting stuff on leak detection too, and we're joined by folks from in Canada. First up this morning is David Shaw, who is an executive consultant with Kiefner and Associates. As a lot of you probably know, Kiefner and Associates just a few years ago, and I usually get the year wrong, 2011, 2012, did a big study for PHMSA on leak detection, and it made the press a lot. So we're starting off with David, and he's going to talk a little bit about that and then some of his views on whether we can really get to leak detection versus just rupture detection. David.
Okay. Thanks very much, Carl. Good morning, folks. The only reason I'm going first is because essentially, I've got 15 minutes in which to tee up some really interesting presentations of the other folks. So I'm going to do Mission Impossible, which is to try and introduce leak detection and some of its major issues to you first of all. Like Carl just said, we worked on a report for PHMSA several years ago now. It was co-authored, by the way, let me acknowledge Martin Phillips. And what I'd also like to do is to give a very, very brief summary of what I think the progress has been since that report was first written. So this session is fairly provocatively called, Is Leak Detection Possible? And the answer is, it depends on what you mean by leak detection. And so I suppose let's start with why do you need leak detection? And a major issue is that, believe me, one way or the other, there will be a loss of containment on your pipeline. It will happen. And so I do sometimes wish I had $1 for every time someone told me, I've got the world's best integrity management program in the world. Why would I need leak detection? The leaks will never happen. The other thing is, and rightly, there's a laser focus on avoiding incidents at all costs. The fact is, incidents are going to happen. So perhaps the real question is, given that the incident happened, what are we able to do responsibly to mitigate the consequence of that incident? So in any case, given that the leak will happen, we have a responsibility for detecting and shutting off that loss of containment as quickly and as reliably as possible. So let me start by saying, what do we mean by leak detection? Let's start with what do we mean by a leak. So, and this is a gross oversimplification, but essentially, we've got ruptures, and by ruptures, what we're thinking about is most of the pipeline flow is basically going into the environment. So that's a very large leak, if you will. There are seeps. Now, seeps are happening all the time, and they are notoriously difficult to find, but that's what you have pressure tests for example. So a seep is apparently innocuous, but is left to its own devices for a long period of time, ends up being a very large volume of fluid in the ground, in the environment. And somewhere in between, and again, this is terribly vague, is the leak. And we need a better name for that right there, but these are losses of containment which you're not probably going to find with a rupture detection type system. And because you're only doing hydro tests on a 3-year cycle, you're not going to be able to find using one of those techniques. So in any case, you need to understand what the different landscapes are for different types of leak right there. Now, the other issue is, we just think that a leak is the same to every operator. Well, it's not. It really depends on what kind of operator you are. And dramatically different are the natural gas operators and the liquids operators. To a liquids operator, a leak of any size is pretty catastrophic because it ends up in the ground, it contaminates people's farms, people's rivers, and the environment. A natural gas operator, I hate to say this, lives with a whole bunch of leaks going on right now. And there the issue is completely different. There the issue is time to response. They need to be able, when they have a fatal leak happening, they don't have time for it to go to the controller, to then do a little bit of error checking, to then go off and close off some valves and everything else. No, they need it to shut down right then. So I think that they also have another even worse problem, which is it's not the size of their leak that matters, it's the concentration of their leak that matters. So, most of the worst disasters have been actually quite small gas leaks, which accumulated and developed, a combustion point and then exploded. And those are the worst kinds of leaks to try and detect. The session this morning talked quite a lot about information sharing and trying to develop key performance metrics and so forth. And we got a lot of flack for the very last quote on this slide. This is math. If somebody goes in and actually works out how many reported incidents were reported as being detected by the controller, it's 17% of all reported loss and containment incidents. Now, first blush, that looks pretty terrible. And that's one of the problems, I think, with leak detection. This is one of the reasons that you sometimes hear that leak detection just doesn't work. Everything else is better and we should be able to look for something completely different. Well, that's not the truth, because one other thing to mention, I've already touched on this, leak detection takes all forms. Right-of-way patrols are a form of leak detection. I mean, they're not very timely, and they're not very accurate, or sensitive, I should say, but they are a form of leak detection, and overflights and all the pressure testing I mentioned are all forms of leak detection. So I think that, looked at more globally with a bigger spectrum, it's way better than 17%, believe me. So I also wanted to move on to the flip side, which is that operators really, really want a leak detection system to be an instrument. They want to have something that's ASTM certified, it's got a 6 Sigma reliability, it goes on every time there's a leak, and it switches off every time the leak is fixed. It's not. Unfortunately, because of the nature of the beast, we're simply never going to get to that level of accuracy and reliability. And what is sensitivity? I mean, sensitivity, we mentioned, can it get a small leak, a large rupture, or a medium leak, is not enough either, because there is an associated reliability number with that. So while perhaps in the back of your minds you're thinking at least rupture detection might be a little easier, remember the issue isn't, can I detect a rupture, which you can. The question is, can I detect a rupture totally reliably? Because when I do detect it, I'm going to be shutting down the pipeline. It's going to have to be, well, it'll have to be up in the 6 Sigma range. So just because rupture detection sounds technically easier, it doesn't make it practically any easier, because you do need that associated very high level of consequence in the alarm. Now, I said this a little bit earlier, but the real advice that came from our report, if there was any advice, was that if you're going to design a really good leak detection system, you can't really rely on one single technology. Typically what happens is that certain technologies are going to be very good at the seeps, certain technologies will be very good at the big ruptures, and certain technologies are going to be very good at the medium ones. So you don't go out and you say, I want me a leak detection system, sell me one. You go and you decide on what you need. You go and you decide on what your targets are, what your thresholds of acceptable performance are going to be. And then you do a defense in depth strategy. So what you're trying to do is you're trying to build in system redundancy. All fields of engineering aim to do this. This is a whole lot more complicated, though, because you're dealing with various technologies, processes, training, and so forth. Let me also say another big problem. Operators, of course, tend to prefer to use a leak detection system based on stuff they have anyway. So liquids operators who already have custody transfer grade metering like to repurpose the same meters to go ahead and do material balance types of leak detection. If you don't have meters, they say, well, I'm not going to put in a meter, I'm going to use pressure monitoring or something like that. So, and the visual inspection is a classic one, because you're kind of driven to do that anyway by integrity management kind of requirements. So there's a temptation to do leak detection as an afterthought with systems that you've already got in place for completely other reasons. So in any case, I think that there is a certain amount of difficulty explaining to operators how much is important in leak detection itself. Now, one final thing I will say, because is that a leak detection system is a system. So there is a tendency to look for a technology, the silver bullet, that's going to work and it's going to give you an alarm and so forth, but experience, and you speak to operators about this, experience is that people factors are enormous. I mean, your controller has got to understand how the leak detection system works. Not to the mathematical detail, but he's got to know what it relies upon and what other things might actually cause a false alarm, for example. And there has to be a process, like I mentioned. A leak alarm goes off, you're on the clock. I mean, the stopwatch starts. You have to begin to think about whether you're going to shut down the pipeline now or not, or how long you're going to wait, or what the escalation process is going to be. So the entire system of the leak detection is just as important sometimes as the technology that gets used. I did mention that I'd like to now talk a little bit about what developments, and I want to say recent, but it's since 2012, so that's a solid 4 years ago, is that, first of all, API and AOPL have been very active in this area, and so they did recognize that the process and the people aspect of things is important. So a recommended practice 1175 was ground up. It's what they call a leak detection program. It's the programmatic side of leak detection. And it's a fairly weighty tome, and it concentrates on the program side of things. Let me also acknowledge PHMSA has also funded R&D in this area, looking for a whole full life cycle approach to leak detection systems. So that, again, you're not simply going out there and checking off a box and I've got a leak detection system and I walk away from it. So the life cycle issue is very important, and that's been addressed kind of recently as well. I'd also like to say, now without getting too jargony here, external sensor-based leak detection, ironically you'd think that the most logical, perhaps most logical way of doing leak detection is to detect the leak outside once it's come out of the pipe. Actually, that is not the case, certainly not with liquid systems. Most people actually do meter-to-meter balancing. But more recently, and I'd say this is over the last couple of years at most, there's been a renewed interest, both from a technical point of view and an actual implementation point of view of external sensor-based leak detection systems. My background is mathematics. Certain very nerdy statistical techniques that I would say in 2012 were beginning to get introduced are now becoming fairly mainstream. In fact, perhaps one of the industry-leading internal leak detection system vendors is based on some fairly advanced statistical techniques. And I suppose, finally, I'd like to say that there's been an interesting funnel of new R&D. So by funnel, I mean, this is still a long way from becoming a practical bolt-on leak detection technology. But we do have a lot of initiatives from research institutions and from the API at the pure technical level, and this is across the board. We've got all kinds of stuff going from artificial intelligence to self-organizing networks. The use of drones, I mean, is pretty classic, but that's even getting leapfrogged by the promise of perhaps being able to do satellite-based visual inspection as well. So the other thing is the operators are beginning to get involved in the front-end R&D. They always were interested in field trials, but I do know of at least half a dozen operators who are actively in the funnel mouth, if you like, of the technical side. So that's all I have time for, and so there'll be at least 3 other topics here to talk about, but look forward to hearing the rest of the presentations. Thank you, David.
Thank you, David.